Okay, so we're going to take a kind of look at the range here. And probably the best way to identify the range is how we've been identifying the range visually throughout most of these earlier units. So what I'm going to do here is just set up a little sketch of a graph right here. And then I'm going to go ahead and graph this right into my calculator to take a look at it. We're going to look at a table and we're going to look at a graph. All right, so I've got -6 plus radical 2 minus x. So you can see in y1, I've got -6 plus 2 minus radical x. Make sure everything is underneath the radical before you graph. And then I'm going to go ahead and take a look at the graph. And you see here, as I travel along, you can see the graph kind of stops or ends at a point right there, okay? And that point is the point 2 comma -6, right? So the lowest y value you see, if you look at the top left of the screen, the y values are going up now, right? They're going up, they're going up, they're going up, they're going up, they're going up. They're just going to keep continuing going up forever, all right? But as we approach the right-hand side, the lowest this possible x value goes would be 6. So what I'm going to say here is that if I sketch a graph of this right here, I've got this point right here. This is the point 2 comma -6. And I know my graph goes on forever. So I'm going to say for the range, I'm going to say y is greater than or equal to 6, right? Or if you want to use interval notation, you can say, I'm sorry, why did I put 0 there? It's greater than or equal to -6, right? The y value is the lowest y value that's in there, okay? So y is greater than or equal to -6, or I could say -6 runs all the way on to positive infinity. And make sure if we're heading to positive infinity that our lower number is listed first. So -6 is our lower number, and then it's going up to positive infinity forever, okay? One thing to notice here is I've got a plus right here and a minus right here. So let's see if that makes a difference in our graphs. So if I go ahead and take a look at this, I'm going to close this out. Now I'm going to turn on my y2, which is 5 minus radical x minus 6. Make sure that all the values are underneath the radical in your graph, okay? And if I'm going to go ahead and look at the graph, I'm going to see here that I have a point right here, which is the point 6 comma 5, right? So 5 is the highest y value, and you can see that, look, y is going down now. 3, and then 2, and then 1, and then I'll just go down forever, right? So if I'm going to go ahead and sketch a graph of that, what I would look at here is, I'm going to just draw a little coordinate plane real quick. I label my x, I've got my y, right? I've got the point 6 comma 5 right here, and the value is just going to keep going down and down and down forever, right? And this point 6 comma 5 is going to give us a value. So what can we say here now, right? So now we can say, well, y is less than or equal to 5, okay? Or if I want to list this in notation, now I can say, well, it runs all the way from negative infinity, right, to the value of 5. So it's a little bit hard sometimes when you list that, okay? So you want to start with negative infinity and then list a value as 5 and then lock that in there, okay? Last but not least, you can always take a look at your table. Now my table, it looks a little bit differently, but I'm going to turn both of these on. My table will have zeros in there, which it's not really 0. You can see, but there's our point 2 comma -6, right? And then your calculator will say error, because it doesn't exist. Okay, for some reason my calculator has 0. And you can see in this point, right? Here's our point 6 comma 5. So 5 is the y value, and it just goes down forever and ever and ever. All right? Hope this helps.